Okay, good morning to one and all. This is Cyril Prasanna Raj, working as professor and Dean R&D in Department of EC, MS Engineering College. Once again, good morning to all the students. Please note down my email ID for any queries. Today, from today onwards, we would be discussing about communication systems pertaining to the basic electronics. So the contents for my sessions are as follows. According to the prescribed syllabus by VTU, Module 5 contents are, there are two units, one is communication, the other one is transducers. So communication, we need to understand the importance of communication, the communication systems, and we also need to understand the three important analog modulation techniques such as amplitude modulation, frequency modulation, and phase modulation. And finally, before we could conclude that session, we may have to also understand how do we compare all the modulation schemes and what are the advantages, applications where these modulation schemes can be actually used. Further, we will also be able to discuss on the importance of transducers. In transducers, they have the syllabus asks us to go through the following transducers such as thermistors, thermometers, linear variable differential transformers, and piezoelectric transducers. So we will be trying to understand what are the what is working principle behind these transducers, and what are the applications where these transducers are going to be used. So these two units basically forms module 5, and you may be wondering why we may have to combine communication with the transducers. So to stress very briefly tell you about communication basically refers to transmission of signals from one source to a destination. As we transmit data from a source to a destination, we may have to acquire data from real world. The data that we are going to acquire from real world are called as physical quantities. So for example, when I speak, that is a physical quantity. So speech is actually a physical quantity. And how is speech produced? As I start speaking, I try to open my mouth, I try to modulate my air that is basically coming out from my lungs, and then I move my lips, teeth, and all these things to start creating vibrations. So when I start speaking, the vibrations are actually created, and we call these as physical quantities. These vibrations, they travel over the air media, and as they reach the ear of a human being, the diaphragm in the ear starts vibrating. As it starts vibrating, there are some biological changes that are occurring, and these biological changes are captured by the brain signals, and then we understand what is it person is trying to talk about. So if at all we would like to capture these physical quantities, assume that I would like to capture my speech. So what is the process that is available? So I need to have a method, or I need to have a device to capture these physical quantities, and that device is what is basically your transducer. Particularly to capture speech data, we may have to use a transducer called microphone. A microphone is a device which basically consists of a magnetic device inside that, which is having a diaphragm in front of it. So as the speech signal, that is a physical quantity, starts vibrating and starts falling on the diaphragm, so you have a diaphragm and the signal starts falling on the diaphragm starts vibrating. Because of vibrations created by the diaphragm, there will be a magnet available and diaphragm starts vibrating. So what happens? The magnetic flux gets disturbed. So what happens? The magnetic flux will now change the current that can flow in a device. So what is happening is we are able to use the transducer like a microphone, which is able to capture the real time signal like speech and convert it into an electrical signal. So once we convert that into an electrical signal, that signal is now taken to a mobile phone or taken to any of the devices for further processing, and once a processing is done, we may have to transmit that signal over communication channel so that it can reach one source to multiple destinations. So if you try to understand, the important factor here in a communication system is the transducer. Without a transducer, it is not possible for us to capture real time signal. That is why this module, we find that there is transducers combined with communication systems. So, I just give a small illustration why transducers are very much important and why that has been combined with communication systems. So, what we actually try to do here is, let us now understand what is communication system is, and then also understand what are the types of communication systems, particularly the analog communication system, and in analog communication what are the 3 different techniques of performing modulation. Okay. So, we will try to get into the details of all this and then see how do we compare them at the end of today's process, right. Okay. So, the recommended reference books are, apart from the things whatever has been given in the VTU syllabus, there are lots of information that is available in this book titled An Introduction to Analog and Digital Communication by Heiken. Okay, it is a Wiley publications, plus you can also refer to Communication Systems by Carlson, and it is again McGraw-Hill publication. Now, if at all you would like to get more understanding about communication system at a very simpler language, I have given some of the websites, and you will be able to see all these websites are able to provide you lots of information pertaining to communication. And the last web link basically from the EduCypedia, okay, from the Berkeley University, you will be able to also understand how communication is actually being done. You can use lots of they have used lots of animations, lots of videos, lots of YouTube videos are available, which you can really go through that to understand what communication is all about. So, the picture what you are able to see below, okay, that picture basically illustrates the importance of communication. So, if there are, you will be able to see lots of buildings, lots of mobile phones, lots of towers, lots of cars, all these are basically available on this earth, and all these are basically involved in the process of communication. So, whenever we tell communication or electronic communication particularly, it is basically transmitting of data from a source to a destination, or from a source to multiple destination, or it will be a two-way process also. So, let us now get into the details of what is communication is all about, right. Now, let us understand the very basic aspects of communication, the definition of communication. Okay. Now, this is all the where the communication is being defined in many books. Many authors have used this definition to just tell what communication is all about. So, communication is the transfer of information from one place to another. This should be carried out as efficiently as possible, with as much fidelity, reliability as possible, as securely as possible. So, there are 3 or 4 important terminologies that we may have to remember when we start defining communication. The first and foremost important terminology is communication is transfer of information. So, let us understand what do you mean by transfer of information. So, information basically is, suppose there are lots of activities going on, okay, and these activities every day there are lots of activities going on in our daily life. Now, there are certain incidences which we call them as information. For example, assume that I keep walking and then I meet my friend, that is an incident, and that is what an information to me. Now, that is this information which is having the least probability. So, we try to tell information in terms of probability. If there is more information, less amount of probability, and less amount of probability, it is more amount of information. So, the information that we gather from one source, if we can transfer that information from one place to another place, okay, as we keep transferring the information from a source to a destination, it is also required that the information should be efficiently transferred, it should be reliable, so that the person on the other side is able to understand, okay, this is the reliable information I am able to get, plus it should also be secured so that nobody is able to hack the information. So, whenever we talk about communication, the 4 important terminologies which describe communication is transfer of information, plus transferring this information as efficiently as possible, and it should be more reliable, and it should be more secure. And that is what is the basic definition of communication. Now, let us understand what is the basic block diagram in communication system. The basic block diagram in a communication system is as follows. So, you have an input message. As I mentioned earlier, an input message is basically the physical quantity. speech is one of the physical quantities, audio is a physical quantity, video is a physical quantity, or if I try to capture pressure, temperature, all these are basically your physical quantities. These physical quantities are captured by a transducer, or in particular we call it as a sensor. Why sensor? Because any physical quantity which has been captured, and if it is converted to an electrical signal, we call them as sensors. So let us understand this, it is a very important point to be noted down. So any physical quantity, if it is captured and converted to an electrical signal, we call that device as a sensor. A sensor is a part of a transducer. Sensor is also a transducer, but we specifically call it as sensor because physical quantities are captured and converted to an electrical signal. So we call it as sensor. Now the electrical signal that is coming out from a sensor is given to a unit called the transmitter. The purpose of the transmitter is to take this electrical signal, which is a raw data, and do some processing on this electrical signal. Why are we supposed to do the processing? We will understand that in detail, but the processing that is basically done by the transmitter is to ensure that the signal that is going to be launched onto the channel, the signal that is going to be launched onto the channel, there is a compatibility between the signal and the channel. So to ensure that there is a compatibility of the signal that will be traveling on the channel, you may have to do some processing, and that processing is actually done by the transmitter. So let us understand what is the major role of a transmitter. The major role of a transmitter is it has to take the electrical signal that is consisting of information, and it has to do certain processing on the electrical signal and translate some of the parameters of this electrical signal as compatible to the channel parameters, so that the signal can travel on the channel efficiently, in a reliable manner and secured manner. Once the signal is able to travel over the channel, the signal will now start reaching multiple destinations. As the signal reaches one of the destinations, we will have a receiver. So any receiver can capture the signals coming out of these channels. As receiver at the other side, that is we call it as the destination side, will capture the signals coming out of a channel, and then what this receiver will try to now do is, from the received data, it will start processing the information and collect only the information that is required by the destination. So the receiver will now try to extract information from the signal received, and that information will be now captured and it will be in an electrical form. Now the signal that is available in the electrical form, if at all it has to be converted back to a physical quantity. What I mean by physical quantity is, suppose an electrical signal is now received by a receiver and I would like to hear the electrical signal. So if at all you would like to hear the electrical signal, you will convert the electrical signal back to physical quantity, we may use a speaker. Like normal speaker, whatever we have in our home, whatever we may have in a mobile phone, we have multiple speakers. So a speaker is called as an actuator. A speaker is called as an actuator because a speaker will now receive electrical signal as the input, and it will now convert that electrical signal to vibrations, and these vibrations would be in the audible range. So what happens in an actuator now? It will be a reverse process of a microphone. In an actuator, what you find is, now you have a magnet, then there is a wire connected across the magnet, plus you have a diaphragm. So what happens, whenever the receiver sends a signal through the wire will now ensure that the magnetic flux around the magnet starts changing. Because of the magnetic flux which is being changed now, the vibrations will start, the diaphragm will start vibrating. The vibration of the diaphragm will now change the physical quantities, you are able to produce audio signal. So the complete block diagram of a communication system, if you try to understand, you have an input message, which is a physical quantity. We will assume that it is a speech signal and it is now captured by a sensor. A microphone is a sensor which is converting the speech signal to an electrical signal. The electrical signal is now being pre-processed, or it is being processed by the transmitter to ensure that the signal is now compatible to a signal available on the channel. The channel is the medium that is able to carry the, it is able to ensure that the signal is present in the channel, and the signal now reaches the receiver. At the receiver, you do the post processing. You now try to extract the information from the received signal, and then what we do is we take the received signal and convert it back to physical quantity using an actuator. A simple example for an actuator is like your speaker. Now we are able to get the message. So these are the basic building blocks of a communication system. Now let us understand what are the elements of communication. So the elements of communication we have discussed. So let me read it out once again. So the input signal is a real-time signal. It could be speech, it could be image, it could be video, it could be audio. So these real-time signals are being captured, okay, and these capturing devices we call them as specifically transducers, and now I am just calling them as sensors in particular because all these signals, physical quantities, are converted back to electrical signal. Now the signal that are being received from a sensor are now being processed before transmission. Now once the signals are being processed, now we have a transmitter. We know we are supposed to send the signal to the channel. The channel is a complete open space now. Now the electrical signals that are available from the transmitter module, if at all it has to be launched onto a channel, okay. So the signal that is available in a channel, we call them as electromagnetic wave. So the picture what you see here, okay, this is a simple picture illustrating what is an electromagnetic wave. So this is an electromagnetic wave. If you find in an electromagnetic wave, the electric field is perpendicular to magnetic field. So you are able to find that there is a electromagnetic wave wherein the electrical field will be perpendicular to the magnetic field. So this is how an electromagnetic wave is present in a channel. So a signal, if at all it has to be transmitted, it is transmitted in the form of electromagnetic wave. So what you see here is again a electromagnetic wave, another representation of electromagnetic wave. Again you find there is an antenna, again there is an electromagnetic wave. So this is what is an electromagnetic wave. So to generate an electromagnetic wave, you need to have an antenna, okay. So what happens is at the transmitter side, okay, you have a sensor and then a transmitter. Output of the transmitter is now connected to an antenna. What is an antenna? So antenna is a very simple device, okay. So let me take a simple conductor. This is a conductor now, or let me take a conductor. This is a conductor. A simple wire, maybe a copper, aluminum, or whatever. This is a simple wire. So this is a conductor now. So what happens in a conductor is whenever the current starts flowing in a conductor, according to Faraday's law, what it states in Faraday's law, it states that whenever current flows through a conductor, there will be a magnetic field perpendicular to the direction of the current. Now the current that can flow through a conductor should be always an alternating current. So let us understand, the current that can flow through an antenna, which is a wire, okay, should be an alternating current. Only then we will be able to produce a magnetic field. This magnetic field will further ensure that there is a perpendicular electric field produced. So to generate an electromagnetic wave, the requirement is you need to have an alternating current that can drive a conductor or a wire or an antenna. So whenever an alternating current, like alternating current, when it tries to drive an antenna, it will start producing electromagnetic waves, and these electromagnetic waves are able to propagate over the channel. So the important building blocks of an communication system are, as I mentioned, you have an input signal, you have a transducer to capture the real-time data, convert it into an electrical signal, then you have a transmitter that can process the electrical signal, and then you have an antenna at the transmitter side which can convert the electrical signal to electromagnetic wave. Now this electromagnetic wave are able to now travel over the communication channel. As they start moving over the communication channel, there are possibilities, there are chances that these channels, these signals will be interfered by multiple other signals, and there will be a noise also available on the channel. So the challenge today is whenever we try to transmit a data from a source to a destination through a channel, okay, on the channel there will be lots of interference occurring, there will be lots of noise coming up into picture, there will be lots of signals which are available on the channel. These noise and these interferences will ensure that the signal will get corrupted. Now the challenge now available to the receiver is the signal that is now being transmitting or that is being traveling over the channel will reach the receiver. Along with the signal that is also reaching the receiver, you may also receive the noise. So the receiver now has a bigger role to play. The receiver has to now take the signal plus the noise and ensure that it is able to discard the noise and extract only the information from the signal, and that is the basic purpose of a receiver. The receiver has to ensure that the signal along with the noise that is reaching at the input of the receiver is now being processed, and the receiver ensures that it only removes the noise and extracts the information from the received data. So the fundamental building blocks of any communication system are input signal, this real time, you have a transducer, your transmitting module, plus an antenna at the transmitter, plus an antenna also at the receiver. Okay, so you are able to transmit, you are able to receive. The antenna at the receiver will now, then you also have a channel in between the antennas, and then the antenna whatever you are able to have at the receiver will be taken to a receiver section wherein you do the processing and get back the signal. Right. Okay. So now these are the basic fundamental building blocks of a communication system. So remember, you have an electromagnetic wave available in the channel. Okay. Now let us understand what is this electromagnetic spectrum. Okay. So as long as we are communication students, as long as we study the basic electronics course, we should also be aware of what is this electromagnetic spectrum is all about. It's a very standard way of understanding what is electromagnetic spectrum. Okay. So the electromagnetic spectrum, okay, it is divided in terms of frequencies. So when we talk about frequencies, it can start from 30 hertz, very low frequency, to 300 gigahertz. So it can start from very low frequency, that is around 30 hertz, okay, and it can go up beyond 300 gigahertz. So the electromagnetic spectrum, okay, which has been standardized, describes various bands that are available in this spectrum, starting from 30 hertz to 300 gigahertz. Now, any frequencies that are in the range of 30 to 300 hertz, okay, that is a very low frequency, okay, we call them as extremely low frequency, or from 300 to 3000 hertz we again call them as voice frequencies. Okay, so it is usually the speech data. Okay, whatever we speak, whatever many people start speaking, all these speech signals, either it is a man or a human being, whatever the speech signals, all these signals that we speak are in the range of 30 hertz to 3 kilohertz. Okay, it's a very important point to be remembered, so that as a engineering student we understand the audio frequency range. The audio frequency range is 30 hertz to 3 kilohertz, or in general we can call it as 20 hertz to 4 kilohertz. Now the next important frequency spectrum is the frequencies which all of us can hear, that is a frequency range that can start from 30 hertz to 20 kilohertz, or we can generally call it as 20 hertz to 20 kilohertz. This is what we call it as the audio frequency range. So whatever we speak is just 4 kilohertz is the maximum frequency, but whatever we are able to hear, for example, if I make a noise like this is audio, that frequency is not, it can be within 30 to 20 kilohertz. Okay, it is within the range of 30 to 20 kilohertz. Now if I start banging this table, the audio signal what we are able to receive, okay, that is basically in the range of 30 to 20 kilohertz. So all those signals which are audible to us, okay, we call them as audio signals which are in the range of 20 to 20 kilohertz, and whatever the signals we are able to hear, like speak, that signal is in the range of 300 hertz to 3000 hertz. Okay, so let us now understand there are two important frequencies which are very important for us, because one is called as the speech signal, the other one is called as audio signal. Okay, speech signal is between the range of 20 to 4 kilohertz, or it can also be 300 to 3000 kilohertz, and the audio frequency is between 20 hertz to 20 kilohertz. Now the term anything above 20 kilohertz we call it as low frequency, and we have medium frequencies, okay, and your AM radio, okay, which is all operating in kilohertz range, it will be from 535 kilohertz 535 hertz to 1605 kilohertz. Okay, high frequency wherein all the broadcasting keep happening, and these broadcasting are in the range of 3 to 30 megahertz. And if you try to see the very high frequency, that is basically from 30 hertz to 30 megahertz to 300 megahertz. And that is where you come across all the FM radios. You have 92.7 FM, 101.1 FM. They're all in this range of 30 hertz megahertz to 300 megahertz, and particularly the FM broadcasting happens between a frequency range of 88 megahertz to 108 megahertz. Okay. Now we also have another band of frequencies called as the ultra high frequencies. These ultra high frequencies where the TV channels are being operated, it is from 300 megahertz to 3000 megahertz. Okay, and that's also a very important terminology to understand, because suppose if somebody asks us what is the operating range, operating frequency of our cellular phones, mobile phones, the operating frequencies of mobile phones are in the range of 300 megahertz to 3000 megahertz. Okay. So it is usually your BSNL operates at 900 megahertz, Vodafone, they are operating in the range of 900 megahertz to 1800 megahertz. Okay. This is another very important factor to be remembered. Okay. Yeah. Now there is another very high frequency called as the microwaves, wherein satellite communication happen, wireless LANs they work. That is in the range of 1 gigahertz to 30 gigahertz. It's a very important frequency. Suppose if at all I would like to transmit data over wireless system, maybe I am using a Bluetooth, I am using a Zigbee, or I am using any short range wireless communication system. They all operate in the range of 1 gigahertz to 30 gigahertz. Now extremely high frequencies, any frequency that is between 30 to 300 gigahertz, we call them as extremely high frequencies, which is all basically used for defense purpose, and radar signals, all this operate at these extremely high frequencies. Okay, and these are the ranges of your electromagnetic spectrum. Let me summarize some of the important factors here. Let me go back. So the important factor that we may have to understand here is, one is the speech signal. The speech signal is between 300 hertz to 3000 hertz, or in general we tell it as 3 hertz to 3 kilohertz. Audio signal, it is in the range of 20 hertz to 20 kilohertz. Okay, that is the important factor that need to be understood. Second important thing is the FM radio operates at a frequency of 88 megahertz to 108 megahertz. Okay, that is another very important factor to be remembered. Plus your cellular phones, that is mobile phones, they operate at a frequency of 300 megahertz to 3000 megahertz. And lastly, your wireless system, wireless LAN, they operate at 1 gigahertz to 30 gigahertz. Okay, that is what is an electronic spectrum. Let us also understand very important aspect, the figure what you see at the bottom. Okay, the figure what you see at the bottom, this picture illustrates what is the range of frequencies that are what is the electromagnetic spectrum in terms of the frequencies. So you see that there is a 300 hertz at the left hand side, and it keeps going on up to 300 terahertz. Okay. Now as we listed out all the frequencies, as we keep going from low frequency to high frequency, we term it as VLF, LF, MF, HF, VHF, UHF, and so on. Okay. At the same time, there is another important parameter that is also available there. One is the parameter that is above the frequency is called as the wavelength. Okay. Wavelength is basically the distance travelled by the signal in doing one complete cycle is called as wavelength. So if you see the wavelength, as you have a lower frequency, the wavelength is 1 megameter, and as you keep increasing the frequency, and the frequency if it has reached 300 terahertz, the wavelength has been reduced to 1 micrometer. So wavelength is inversely proportional to frequency. So it's a very important term to be remembered. Frequency and wavelength are inversely proportional. Okay. So let us understand why is this formula more important for us. Okay. As we keep understanding the modulation factor, we will try to learn more about what is the importance of wavelength and what is the importance of frequency. So before we could go to the next slide, so let us understand what is that. Wavelength is inversely proportional to frequency. As the frequency is very high, wavelength would be very small, and as the frequency is very low, wavelength of the signal will be very high. Okay. Let us now understand the other aspects. Okay. Let us summarize. Okay. So the summary of the process today that we just understood in the from the previous discussion is speech signal is between 20 Hertz to 4 kilohertz, and audio signal is between 20 Hertz to 20 kilohertz. These are all the important factors. Then your FM radio operates at a frequency of 88 megahertz to 108 megahertz, and your mobile communication is basically 900 megahertz to 1800 megahertz. So let us understand or remember these frequency components. Okay, now there are three components of a communication system, and these three components of communication system are the transducer, okay, then the transmitter receiver module, and the channel. The transducer, so we find that the front end of any transmitter will have a transducer. We generally call it as a sensor, which will capture physical quantity, convert that into a electrical signal. Then as the signal is now being processed by the transmitter, before the signal could be launched onto a channel, we have an antenna that converts electrical signal to electromagnetic wave. So that is also called as transducer, or we simply call it as actuator, right? So there are two transducers used at the transmitter. One is to capture physical quantity and convert it into an electrical signal, and the other transducer is at the transmitter end, wherein we try to convert electrical signal back to electromagnetic wave. And the signal now traveling over the channel will be now again interfered by an antenna, which will convert electromagnetic wave to a electrical signal. Now that is again an antenna at the receiver. Now the received data will be now processed by the receiver module, and it will be able to give you a signal, and that electrical signal has to be now converted back to your physical quantity. We again use a speaker, which is also a transducer, or we simply call it as a actuator. So a transducer is a very important module in a communication system. Now the signals that are being captured by the transducer are being processed both at the transmitter side as well as at the receiver side. So we call them as the transmitter receiver modules, and they are particularly used for processing of signals. Now once the signals are being processed by the transmitter, the signal has to travel over a medium, and we call that medium as a channel, and this channel can be either wired or it could be wireless. So whenever a signal is now being traveling on the channel, the signal will be traveling in terms of electromagnetic wave, and the signal will be now received at the receiver for further processing, and this is what is going to happen in a wireless communication system, right? Okay, let us now go to the next important subtopic of today's discussion, is that is your now let us also understand the exercise 1. So if at all you would like to understand more about these exercises, so the important terminology or important factor or important question that could be asked: define communication and discuss the elements of communication system. Okay, this is a typical question that would be asked for maybe 5 marks or 3 marks. So they may ask you, define communication and discuss the elements of communication systems. Second thing is, briefly discuss the electromagnetic spectrum representing the frequency, wavelength and operating bands and its applications. So this is another kind of question that could be asked from the topics whatever we discussed till date, right? If at all you would like to know more about these solutions, please visit www.research.mscc.ac.in. We have a ebook facility available there. All this information is available. You will be able to get more information to understand what is communication system is all about, plus also understand the solutions for this exercise, right? Okay. Now let us get into the next important subtopic, that is modulation. Okay. Let me first of all define what is modulation. Okay. Modulation, okay, is a process wherein, okay, it according to the definition, in modulation a message signal which contains the information is used to control the parameters of a carrier signal so as to impress the information onto the carrier. That is what modulation is. Or in general, let us define what modulation is. A modulation is a process wherein the information signal that is been coming out from a sensor, okay, is now translated to the signal that is compatible to the channel, and that is what we call it as modulation. So the building blocks of modulation are, see, if you see the picture there, on one side what you have is, on one side we have basically a microphone. A microphone exists here. sorry. So we have a microphone on one side, okay. So we have a microphone on one side, which is basically a sensor which is capturing a signal, and that signal, since it is assumed that it is capturing speech signal, it is in the range of 20 hertz to 4 kilohertz. This signal captured from microphone, which is in the range of 20 hertz to 4 kilohertz, is now taken to an amplifier where the amplification is actually done. So this amplifier amplifies the signal. Now this amplification is basically a process wherein the microphone would be capturing a data, and the output of a microphone would be in terms of electrical signal, and the strength of the electrical signal will be very weak, it will be very small. To ensure that the strength of the signal is going to be improved, we give it to an amplifier. The amplifier will be able to amplify the signal and increase the strength. That is, we are trying to amplify the amplification, or we try to increase the amplitude of the signal, and that is where an amplifier is used. Now the signal that is coming from an amplifier, it is called as baseband signal. So it is a very important concept in communication, and it is called as baseband signal. The baseband signal, usually in our case, it is 20 hertz to 4 kilohertz. Now this baseband signal that is available at the output of an amplifier, if at all it has been transmitted through an antenna, if at all you want to transmit that signal through an antenna, you are supposed to perform two important processes. The two important processes, the first important process is the modulation. So modulation involves an input signal, okay, you have an input signal here, plus you have a carrier signal here, okay, there is a carrier signal, and these two signals, the carrier signal and the input signal, are basically modulated to produce a modulated carrier, okay. So if you try to see this block diagram there, a baseband signal is now modulated by a carrier signal, and you get a modulated carrier. This modulated carrier is now taken through a power amplifier, and then it is fed into an antenna. So the output of a carrier signal, that is modulated signal, is now amplified and given into an antenna. Usually what happens is, the carrier signal, suppose if at all I would like to if this system is being used in a mobile phone, okay, the carrier signal will be between 900 megahertz to 1800 megahertz, because we have seen the electromagnetic spectrum now. Suppose if at all I would like to transmit the signal over FM channel, so what I should do, I should change the carrier signal here. Instead of 900 megahertz, I can now make it as 100 megahertz. So if at all I change the carrier signal here, I can transmit the incoming data through multiple communication channels. So I can ensure that if the carrier signal is 100 megahertz, if it is going to be FM. If the carrier signal is 900 megahertz, it is going to be mobile communication. So what happens in a modulation is, the baseband signal is translated to a modulating carrier signal before it could be transmitted through an antenna and to a channel. So the process of modulation is basically taking a baseband signal, modulating the baseband signal using a carrier signal of our choice, and getting a modulated carrier which could be transmitted through an antenna onto the channel. That is what is modulation is all about, right? Okay. Now the important building blocks of modulation are, again as I told you, incoming signal is one important building block, okay, then the carrier signal is another building block, okay. So you have two important signals coming into the modulator, the baseband signal and the carrier signal. This is the baseband signal, which is the data that is going to be modulated, it is going to be modulated, that is the information, and the carrier signal, that is what is basically generated locally, and these two things are now going to be modulated, and then you produce a modulating carrier. The process of translating baseband signal to a modulated carrier is called as modulation, okay. So let us redefine what is modulation is. Modulation is a process of translating a baseband signal to a modulated carrier using a high frequency carrier is what we call it as modulation, okay. So in this picture, whatever you are able to see here, this picture, you find that the incoming signal is speech and the outgoing signal is a modulated carrier in the frequency range of 900 megahertz to 1800 megahertz. Now this is achieved because we are selecting an appropriate carrier of 900 megahertz. Now let us see how does this modulation occur. Okay, what is the process of modulation and how does this modulation actually happen? Let us understand the process of modulation. Okay. Now, when we talk about the modulation process, let us see what is modulation. So, whenever we talk about modulation, as I mentioned, there is a baseband signal called, there is a baseband signal called M of t. M of t is called as baseband signal that is coming from a sensor. Now, for this signal to be modulated, we have a carrier signal called as Vc of t. Vc is the signal that is used to carry the modulating signal M of t. Now, if you try to see the carrier signal, this carrier signal is defined mathematically as Vc into cos of omega Ct plus phi c. Okay. So, we are now representing the carrier signal in terms of cos. So, if you see why cos, cos is like, if you take sine, sine is basically like this, cos is 90 degree phase shifted sine. So, we are trying to use these sinusoidal signals as the carrier signal. Now, if you take a sinusoidal signal and if you take a cos signal which is like this, this is the cos signal. Now, this cos signal has an amplitude called as Vc, it has a frequency called omega c, it has a phase called phi c. So, there are three important parameters in the carrier signal. The three important parameters in this carrier signal are the amplitude given by Vc, the frequency given by omega c, the phase of the carrier given by phi c. Now, as I mentioned, the modulating signal will now try to modulate the carrier signal. So, when modulating signal is trying to modulate the carrier signal, what is going to happen now? Suppose if the modulating signal M of t changes Vc, which is Vc is what? Vc is the, if M of t, let me repeat it, if M of t changes the parameters or changes the characteristics of Vc of t, or sorry, Vc. Vc is the amplitude of the carrier. So, what I mean is, suppose if you take a carrier signal, this is the carrier signal, this is the carrier signal. Suppose if I change the carrier amplitude, if the carrier amplitude is changed, frequency is remaining same, but the amplitude of the carrier is being changed according to M of t. If this amplitude of the carrier is basically being changed by M of t, we call that process as amplitude modulation. Okay, let me repeat it. If the modulating signal M of t is able to change the amplitude of the carrier signal Vc, we call it as amplitude modulation. Okay. So, amplitude modulation is M of t manipulates or modulates Vc is called as amplitude modulation. Okay. Now, suppose if M of t changes the omega c of the carrier, if M of t changes omega c of the carrier, we call it as frequency modulation. So, remember, whenever the modulating signal changes the frequency of the carrier, we call it as frequency modulation. Okay. Similarly, if M of t changes the phase information, if at all the phase of a signal of the carrier signal is going to change in accordance to M of t, we call that process as frequency or phase modulation. Okay. So, there are three modulation techniques. The three modulation techniques are what? One is amplitude modulation, wherein the M of t modulates the amplitude of the carrier signal. Second is frequency modulation. In frequency modulation, what happens? The modulating signal M of t modulates the carrier, that is omega c. We call it as frequency modulation. Suppose if M of t modulates phi c of t, that is the phase of the carrier, we call that process as phase modulation. Okay. So, these are the three important analog modulation schemes existing. So, we will understand what are the three modulation schemes available, right? Okay. 2 minutes. Okay. Now the question is, okay, we are now need to understand a very important aspect of modulation. Why modulation, or the advantages of modulation? So to understand the importance of modulation, or to understand the advantages of modulation, okay, so there are three important aspects that we may have to write in an exam, or three aspects that we may have to remember to tell what are the advantages of modulation. The three important aspects that define the advantages of modulation are: one is the length of the antenna, okay, the second parameter is multiple channels, and the third important parameter is, okay, the narrow banding. Okay. So let us understand what are the three important factors that tells us why modulation is a very important task. Okay. So let me first of all take up the first important concept, that is length of antenna. Okay. Now if at all you have a baseband signal at 3 kilohertz frequency, if a baseband signal is at 3 kilohertz frequency, and if at all you want to transmit this baseband signal without modulation using the antenna directly, now the length of the antenna is given by a simple formula which is equal to lambda by 4, where lambda stands for the wavelength of the antenna. Now if you see, lambda is given by c by f, where c stands for the velocity of light and f is the frequency of the signal. So length is now related to c by 4f according to this formula. So now let us see what is this formula is going to tell us. If you take length which is equal to c by 4f, if you are trying to transmit a frequency of 3 kilohertz directly without modulating, the length of the antenna should be now equal to 25 kilometers. So can we imagine having a mobile phone, okay, and you are trying to transmit your speech signal, and the length of the antenna is going to be around 25 kilometers. It is highly impossible to have such a large length of antenna attached to mobile phones. Now by the process of modulation, what we do is we translate 3 kilohertz frequency to 900 megahertz. That is the process of mobile communication, wherein 3 kilohertz frequency, if it is translated to 900 megahertz, what will happen to the length of the antenna? Again, substituting these parameters into this formula, we find that the length of the antenna has been reduced to only 8 centimeters. So if you see the advantage over here, again, if at all you have a low frequency signal like speech 3 kilohertz, if at all you would have to transmit that signal through an antenna, the length of the antenna that is required to transmit and receive should be of very large in size. Instead of transmitting that signal directly, if I take the signal, modulate that signal to 900 megahertz using a carrier, then the length of the antenna has been reduced to 8 centimeters. So the advantage of this is, okay, the advantage of modulation is, okay, you are able to reduce the length of the antenna. So the length of the antenna is reduced if the transmitting and receiving frequencies is greater. So this improves the portability of a device. So that is the first advantage of performing modulation. Now the second advantage of performing modulation is, okay, the multiple channels. So what we do is we will discuss about this aspect in my next session. Okay. So once again I thank you. So please visit our website for more information on these lecture notes. Thank you once again.